So today we are going to see the frictional force acting
Okay.
on an object resting on an inclined plane. Okay,
Okay.
so we have an object here, right? This one, the green box here. It is resting on an inclined plane at an angle of theta. Right? This object has weight, right? Weight that is acting downwards, directly downwards. Okay. Then there's also a normal reaction that is supporting the object.
Yeah.
Other than this, the last one is the frictional force. The frictional force is supporting the object and prevent it from slipping down the inclined plane.
Okay.
So actually we have three forces. Okay. So now let's say how to look at it. Okay. Now we look at this one. Okay. So this one is the weight, the red color here. We transfer from this diagram here to the bigger diagram on the right hand side. Okay. So this is the weight acting on the weight of the object, right? This is the weight of the object, and the weight of the object, they can be resolved into two components. One
All right.
component is this one, which is acting perpendicular to the plane,
Okay.
and another component that is parallel to the plane. So the weight is replaced by the two components. Or if you want, then I show that the weight, this is the weight of the object, mg, right? So if you don't want, or maybe it is equivalent to the two components. So I remove the red arrow and replace it with the two blue arrows here. One perpendicular to the plane and another one parallel to the plane. So these two forces will set up an equilibrium with the other two forces. Okay, so let's say we take this one, right? So this is one component of the weight that is pressing against the inclined plane, right?
Okay.
Now this component is balanced by the normal reaction, the N, the normal reaction, right? Then we look at another one here. Okay, the other component of the weight, mg sine theta, is parallel to the plane. And this component, if not supported by the friction, will cause the object to slide down the plane. But luckily, in this question, we have frictional force. So this frictional force actually oppose the component of the weight. So these two, they balance one another. So as a result, the object is resting at equilibrium on the inclined plane. Okay, so equilibrium means all the forces, they balance one another. And another way of saying it is that the net force acting on the object is zero, right? Equilibrium means the net force acting on the object is zero. Okay, so these are the forces acting on the object, right? So can you read this problem, example 4.6?
As probably shown in the figure, a block having a mass of 4 kg rests on a slope that makes an angle of 30 degrees with a horizontal. If the coefficient of static friction between the block and the surface it rests upon is 0.650, calculate the normal force, the maximum static friction force, and the actual static friction force required to prevent the block from moving. Will the block begin to move or remain at rest?
Okay, right. So now we try to find out what is the weight of this object. So the okay, now the mass of the object is 4 kg. So 4 kg, if we convert it into force, this 4 kg is 4 times 9.8. So the weight of the object is 39.2 newtons. This is the weight of the object, and we are going to resolve this weight into two components, because if you leave the weight like this, right, like this, like this one, okay, which is acting vertically downwards, then we cannot balance. I mean, we cannot see the components that are balancing one another. Okay, so we are going to resolve this 39.2 newtons into two components. So after resolving them into two components, mg cos theta and mg sin theta. Okay, okay, not this one. Okay, so we look at the component that is perpendicular to the inclined plane. So these two components, one component of the weight and the normal reaction, they balance one another. So we say that the N is equals to mg cos theta. So we are going to calculate the normal reaction or the normal force that is supporting the weight, which is mg cos theta. Mg cos theta. So the normal reaction is mg cos theta, 4 times 9.8, and cos of the angle of the inclined plane. And that angle is 30 degrees. So mg cos theta. So multiplying all these three together, the normal component is 33.9 newtons. So this is 33.9 newtons. So knowing this normal reaction, we can calculate the frictional force that is supporting the weight, that is preventing the weight from slipping down the inclined plane. So what is the frictional force? Right. Now, before we carry on with this frictional force, we can actually, earlier on we have learned that there is this static friction. This static friction is not a fixed value. So if you apply a force against the frictional force, and as you increase the force, the static friction will also increase. So it will come to a time when the static friction is maximum, right? So the static friction is not fixed. It keep on increasing until there is, when it reaches the maximum static friction. So it's not fixed. So look, okay, we try to calculate this static friction, right? Now, if we are given the coefficient of friction, coefficient of static friction, this coefficient of static friction is 0.65, and this only happens during the maximum frictional force, right? When it is not the maximum frictional force, we cannot use the coefficient of friction. Okay, right. Okay, so now I hide this, then I show the other one. Okay, I try to calculate the maximum frictional force first. Okay, because the maximum frictional force is equals to the normal reaction multiplied with this coefficient of friction. So I write down there maximum static friction, right? Oh, the word mu is missing. Okay, the maximum static friction is mu n. Okay, mu n. So I try to calculate. Mu is 0.65, and the n, the normal reaction, we have found earlier from part A, 33.9. So the frictional force, maximum frictional force is mu n, mu n. Okay, this is the value of mu, the coefficient of friction, and this is the normal reaction. So when multiply the two together, answer is 22.1. So this is the maximum friction. But whether this is the friction that is acting on the object now or not, we don't know. Because we do not know whether it has reached the maximum friction or not. Okay, sometimes if it is less than the maximum frictional force, we cannot know by using the formula mu n. Mu n is only for the maximum frictional force, right? So we do not know whether in this situation we are having the maximum frictional force or not. We don't know yet, right? So this is the maximum frictional force. We don't know whether the object is experiencing this maximum force or not. Don't know yet. Okay, so now we refer to the next, the two pairs of forces, the friction and the component of the weight. Because the object is not moving, we know that the friction is balanced by the friction balance the component of the weight mg sine theta. So we say that at equilibrium, okay, at equilibrium, the frictional force is mg sine theta, because they are not moving, the object is not moving, so these two forces, they balance one another. Okay, so the frictional force is mg sine theta. So m is 4, g is 9.8, sine is 30 degrees. So when I multiply this together, I only got 19.6 Newton. There's only 19.6 Newton.
Okay.
So when I look at the earlier on, at part B here, the maximum frictional force is 22.1. So we know that in this situation, we have not reached the maximum frictional force yet.
Okay.
The frictional force, 19.6, is below the maximum frictional force, right? This is the maximum they can stand before the object will slide down the inclined plane. This is the maximum value that they can stand, right? The friction can support the object. And now we calculate the component of the weight is only 19.6. So the frictional force that is balancing the component of the weight is also 19.6. So when this true value of the friction in this situation is less than the maximum frictional force, I can safely say that the object will not slide down the plane because it has not reached the maximum frictional force yet. So the object will not slide down the plane. The frictional force can still balance the component of the weight. Okay, so far, any question?
No, understand.
Understand. Okay. So the last part is, will the block begin to move or remain at rest? So because this number here is 19.6, which is less than the maximum frictional force, so the object will not slide down the plane. It will not move. Okay. But If we calculate the component of the weight and this number is more than 22.1, if it is more than 22.1, then the friction can no longer hold the object. The object will slide down the plane, right? So that is the situation where the object will slide down the plane, right? So in this case, it will not slide down the plane. Okay.